Okay troops, in this video we're going to have a look at 3 different types of a resistor. Starting off with this one here, we've met before, it's called a variable resistor, and you can adjust the variable resistor by turning that little black dial there. Next one is called a thermistor. The clue is in the name. This is a resistor. Its resistance depends on the temperature. Right? And this one here is called an LDR, which stands for light dependent resistor. Its little symbol has got arrows pointing towards it. That indicates that there's light shining on it. And it's that little sensor on it, kind of yellow coloured thing, that is the actual LDR. In the thermistor, it's that little green thing that's the thermistor. And in a variable resistor, it's that black dial that controls the resistance of the resistor. So let's look at them one at a time. Okay, first one, I have my variable resistor. Now it says a 22k variable resistor. That means its resistance can go from 0 up to 22,000 ohms. If I turn that, fiddly, if I turn that right the way around, then we can see on my ohm meter, now this isn't a voltmeter or an ammeter, it's been set to, now if you can see that switch there is set to read up to 20,000 ohms. So it's measuring resistance directly, and it's set to measure up to 20,000 ohms. So what I'm going to do is I'm going to adjust that little dial and see what happens to the resistance on the screen. Just now it's reading 4.32. Now that's in kilo ohms. Watch what happens if I turn this little dial up. What's that reading? 5,000, 6,000, 7,000, 8, 9, 10, 11, 12. I can increase that resistance. In fact, I could keep increasing it all the way up to 22,000 ohms. So a variable resistor is useful because you can manually adjust it to be anything you want between 0 and the maximum that's written on it. That's a variable resistor. Now they're used in volume controls and temperature controls and dimmer switches and things. Manual resistor for manual control. Next wee resistor I've got here is my thermistor. The thermistor is actually that little green thing in there. Okay, it's called a bead thermistor. And again, if I measure its resistance directly on a multimeter, remember I'm set at 20,000, just here. So just now my thermistor is 15.36 kilo ohms. Now, here's the magic. If I heat this thermistor up, I'm just going to use my body temperature. If I just put my finger on there, watch the reading. So my finger's on the thermistor, it's sensing that temperature, and from my body heat, as the temperature of the resistor goes up, its resistance goes down. So 14.93, still going down because my body heat is heating up the thermistor. As the temperature goes up, the resistance goes down. If I take my finger off of it, then as it starts to cool down, as the temperature goes down, the resistance goes back up again. Sometimes we say the word turd, T-U-R-D. That stands for as the temperature goes up, the resistance goes down. That's a thermistor. Used in all sorts of automatic temperature circuits. And this final one here, this is our LDR. LDR's the yellow kind of shaped thing with a little spiral sensor on it. An LDR is a light dependent resistor. Just now its resistance is around about 640. It's fluctuating a wee bit. The reason it's fluctuating is because I'm standing over it. Watch what happens when I put my hand over the top. I'm going to cover it. Look at the resistance. It's shot away up. Take my hand out. Back down to 640. It is sensing the motion of my hand blocking out the light. So I'm covering the LDR as the light level goes down. When it's in shadow, its resistance goes up. And then when the light level goes up again, its resistance goes down. Sometimes we use the word LURD, L-U-R-D. When the light goes up, the resistance goes down. And that's an automatic wee resistor that's used in things like automatic night lights or motion sensors. An LDR, light dependent resistor. Okay, I've now got my LDR in a voltage divider circuit with the variable resistor. Remember, these two resistors are sharing that battery voltage. Now that battery is 6 volts. These two resistors are sharing that 6 volts. And I've got a voltmeter across the bottom one. It's reading 0.4 volts. It's 0.41 volts actually. So if there's 0.41 volts across this bottom resistor, it means that there is about 5.6 volts across the top one. And we could measure it just by moving the voltmeter up to the top resistor. But let's just leave it there just now. 0.42 volts. Now the thing about an LDR is, when it gets dark, its resistance goes up. And if its resistance goes up, it's going to get more of a share of the voltage. Watch what happens. Here's the 0.42 volts. If I then cover that LDR with my finger, watch what happens to the voltage. Covering it. The voltage goes up to over 1 volt. Right? I've covered that LDR with my finger. So the share of the voltage that it gets goes up. If I uncover it again, right, in a wee bit. If I uncover it, we're now over 2 volts. If I uncover it, take my finger off it, watch what happens to the voltage. Finger off. That voltage drops away down again to 0.4 volts. So automatically, when it gets dark, that voltage goes way up. Now that's useful, because if we could use that increasing voltage to then turn something else on, we could have an automatic circuit that turns on when it gets dark. The LDR's resistance changes, which causes that voltage to change. Now, because it's a voltage divider, if the resistance of this goes up and the voltage across it goes up, that means the voltage across the top one must go down, so they still add up to 6 volts. It's only one of the resistors that's changing though. The LDR's resistance changes, which means the voltage across it changes. Show you again. Here's the LDR in the bright light. I'm getting 0.42 volts. If I cover it up, that voltage shoots away up. Okay? Automatic change in the voltage due to the change in light level. That's the LDR. Okay, this time we're going to have a little look at a thermistor in a voltage divider circuit with a variable resistor, and they are both sharing a 6 volt battery. Now, again, I've got a voltmeter. Voltmeter is set to 20 volts, so it's reading a maximum of 20 volts. It's reading 2.55, and that's across the bottom resistor, the thermistor. So if there's 2.55 across the bottom bit, there must be 3.45 across the top variable resistor, because they add up to 6 volts. Now the question is, what happens if I cool that thermistor down? If I cool this, I'm going to put an ice cube on it. As remember what we said about thermistors, as the temperature goes up, its resistance goes down. Third, we said temperature up, resistance down. So what will happen if the temperature goes down? Its resistance should go up, which means it should get more of a share of the voltage. Let's try it. Got a couple of ice cubes here. I'm going to cool it down, watch what happens to the voltage. So I'm putting an ice cube on it. If I just leave that there, look at the voltage. Okay, voltage is going up, 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 up. Still going up. We're now at 2.7 volts. As the thermistor cools down, its resistance goes up. So it's getting more of a share of the voltage. If I take the ice cube off, watch the voltage. It's now slowly going back down again. And it will hopefully go back down below 3 volts. There we go. So as the temperature goes down, its resistance goes up. So it gets more of a share of the voltage, so the voltage goes up. And then as it warms back up again, as the temperature goes up, its resistance goes down, so the voltage goes down. And these voltage divider circuits are the sort of key input device for electronic circuits that are automatically controlled, like automatic, your central heating system, automatic cooker turning on and off, or if there was an LDR in there, automatic lights switching on and off. So the next thing we need to talk about is the automatic switch. So let's go over what we were just talking about there. There are 3 different types of resistors that you will meet. They all have the same basic shape, the rectangle shape. But the first one, variable resistor, has an arrow through it. The middle one is a thermistor line through it, which flattens out with a capital T under it. And the LDR has arrows pointing towards it. It's a light dependent resistor. The arrows mean there's light shining on it. Now the first one, the variable resistor, is manually adjusted. It's got a dial or a knob that you would turn, like in a dimmer switch or a volume control or a temperature control. The thermistor, its resistance changes automatically with changes in temperature, hence the name thermistor. And we use the word third, which means as the temperature goes up, the resistance goes down. Or the opposite. Temperature goes down, resistance goes up. The light dependent resistor is kind of similar, but its resistance changes with light levels or brightness. As the light goes up, its resistance goes down. And those are the 3 types of resistors that you might meet in simple electronic circuits. Now let's look at the thermistor in a voltage divider circuit. I'm going to put a variable resistor at the top, which we could manually adjust if we wanted to, and the thermistor at the bottom. Remember, a line through it, which then flattens out with a T underneath it. That's the thermistor. It's a temperature dependent resistor. Now with voltage dividers, remember, if we put a voltmeter across each resistor, those 2 voltages will add up to the supply voltage. And we have our voltage divider equation, which we can use to work out how much voltage each resistor gets. Let's focus on V2, that's the bottom resistor. There's the equation from the equation sheet, where Vs is the supply voltage. Now let's say that supply voltage is 12 volts, and let's say that R1 is 1000 ohms, and R2 is 50 ohms. That's the thermistor. What will V2 be? What will that bottom voltage be? Well, it's the resistor's value over the total of the two of them times the supply voltage. So 50 over 1050 times 12 is 0.57 volts. Quite a low voltage. Now what happens if it gets colder? Well, when it gets cold, the temperature goes down, so the resistance of the thermistor goes up. Remember third, but this time it's the opposite of third. It's the temperature going down, so the resistance goes up. So let's say that the resistance goes up to 200 ohms. The top resistor stays the same, but R2 has gone up. Let's write those values on the voltage divider. And again, let's work out that bottom voltage. So it's R2 over the two of them added together times 12. And that gives us 2 volts. So it's getting more of a share of the voltage. The voltage across the bottom resistor has increased. It's gone up. Now, V1 will have to go down as well because the two of them still have to add together to give 12 volts. But it's the fact that V2 has gone up. This is useful. If we could use this increasing voltage to turn something else on, we need some kind of switch, an automatic switch, which we will meet a little bit later on. The component that we're going to meet is called the transistor. Now don't confuse the transistor. It's an automatic switch. Don't confuse it with a thermistor. It's a resistor. So the transistor is an automatic switch. Now the symbol for a transistor is quite an odd looking symbol. It's got 3 terminals. Okay, now we'll talk about the names of them in the next video. And there's also 2 different types of transistor, 2 different symbols. The first one is called an NPN transistor, and the second one, this one here. So first one, NPN transistor. Second one is called a MOSFET. More about them later.